Hello everyone. So today we will continue over chapter number 8, hacking web servers. And this is the part 2 of chapter number 8. In the part 1, we discussed the definition of web applications. We discussed the different technologies to design a web application. So today we will discuss web application vulnerabilities and countermeasures, how we can avoid those vulnerabilities. So starting with the first agenda item, web application vulnerabilities. So the first thing that we need to understand before we start web application vulnerabilities, first thing that we need to understand is to design a web application, we use different platforms. We use many or different programming languages, for example, Python, JavaScript, PHP, Visual Basics, etc., etc. There are different programming languages that we use. Now, the problem here is that to protect these web applications, the problem is that most of the network security books they completely ignore the programming part. And most of our security professionals, they have also less experience or no experience of programming. So this area, like the web applications, this area is neglected for long, and attackers, they take advantage of that. What I'm trying to say is, like for example, if you have designed an application, a web application using, for example, Python or JavaScript, for example, so there will be some source code, some line of code. Okay, now, there might be some vulnerabilities in the code as well, which might have been ignored. Like, for example, some people, they are attackers. They know the coding problems, and they can exploit. They find the vulnerabilities of your code, and then they can exploit it. Now, the problem is if you use some network security devices, for example, if you have a firewall, if you use firewall or intrusion detection system and stuff like that, these particular devices, they completely ignore HTTP content. Okay, like for example, the request or communication going on between the client browser and the web server. So they actually exchange some data, and then based on those data, they can actually communicate. They can pull information, access data, and stuff like that. Now, the problem is people can actually tamper the HTTP content. They can actually put some malicious tags. They can actually pull some malicious traffic and send the traffic towards the web server, and web server can execute it. That's basically a problematic thing. Why? Because firewall IDS, their main concern is TCP packet. They will see the TCP packet, how the packet look like, whether there's a malicious content and stuff like that. But what about the HTTP requests? What about the handshaking and all that? So these network security devices, they completely ignore the HTTP traffic. So basically what I'm trying to say is the security devices, network security devices, for example, firewall, FW firewall, intrusion detection system, and intrusion prevention systems ignore HTTP traffic, content, or you can say traffic. And therefore, attackers inject malicious tags or traffic inside HTTP traffic and send it to web server to there could be many objectives. One could be to deface a website, for example, to get unauthorized access. For example, it could be steal confidential data, or it could be, for example, you can say launching secondary attacks from those vulnerable web servers by infecting site visitors. Okay, so basically, like the thing is, if regardless of whether there is a firewall or not or stuff like that, if that firewall can be bypassed by injecting the malicious traffic inside the HTTP content, still web applications can be hacked, web application can be defaced, people can get unauthorized access and stuff like that. So basically, rather than using the firewall, rather than totally depending upon on firewall IDS and all that stuff, we have to actually come up with different solutions, and that's basically what we're going to talk about in countermeasures. So let's start with the 10 common or critical vulnerabilities identified by OWASP. OWASP, it stands for Open Web Application Security Project. Web Application Security Project, and that particular project, or this is basically a consortium, a platform which helps the security professionals to find and fight against web application vulnerabilities, attacks, and all that. So this is basically the institute who designed ZAP, Z-Attack Proxy. They actually publish new vulnerabilities. They manage many vulnerabilities, databases and archives as well, just to help the security professionals, security people, so they can be abreast with all the upcoming developments and all. So OWASP, they have identified 10 critical vulnerabilities, 10 most common vulnerabilities through which web applications can be hacked. So let's start discussing those vulnerabilities. The first is the injection vulnerabilities. Injection vulnerabilities are like, for example, let's say this is basically a web server. And now the thing is, for example, and that's the user. The user can be attacker as well. So you whatever user input, for example, this web server, it takes input from user. So rather than or without checking the user input, if that web server execute or process the request, so that means that web server is vulnerable to SQL injection, command injection, or code injection. What I'm trying to say is, for example, this is basically a web server. So this particular web server offers, let's say, if user want to access, for example, this database. So user can actually enter username and password. So rather than putting username and password, if this attacker is injecting some malicious SQL commands, and this web server, when this command get to web server, so web server, for example, if this web server doesn't check whether these commands are valid or invalid and just execute whatever user input, so it means this web server is vulnerable to SQL injection attack or any injection vulnerabilities, because whatever user is inputting, it is basically executing it without checking it. This is called injection vulnerabilities. So injection vulnerabilities are basically, these vulnerabilities occurs when a web application accepts untrusted or malicious data as input from user, or you can say attackers, and execute it without validation. So this is called injection vulnerabilities, and examples are SQL injection attack, SQL injection, command injection, or code injection. We will practice that in our lab. We will use DVWA for practicing injection vulnerabilities. We'll test that. So like you have a web server takes input from user without checking what user has input, it executed. This means the web server is vulnerable to injection vulnerabilities. Like attacker can inject anything in those forms. We will discuss SQL injection in detail and all. Next is the authentication flaws and weaknesses. Authentication flaw means, for example, let's say it occurs because of the poor encryption schemes, encryption schemes, and poor session management. Like for example, if anybody is able to steal your session cookies, anybody is able to decrypt the data without knowing the keying and all that stuff, this is basically called authentication flaws. Like for anybody can sniff it and they can bypass the authentication, they can actually access what you are supposed to access, or they can steal your session cookie. If anybody steal your session cookie in an active session, so let's say this is the website, user has accessed this website. So if somebody steal the session cookie and you are actively on using that website, if they can steal that, they can log in as you during that session and do whatever they want to do. Attack examples are man in the middle attack. We will do that. We will practice man in the middle attack by using AtterCap. The tool is AtterCap. We will use that tool in our lab. And password sniffing. Password sniffing. These are the two common attacks for authentication flaws and vulnerabilities. Number 3 is the cross-site scripting. Just like the injection vulnerabilities, cross-site scripting is basically where web server accept untrusted input from the user. So cross-site scripting, just like injection vulnerabilities, if a web server accepts user, or you can say users, or you can say attackers input without validation, or you can say without checking it out. It means that particular website or server our application is basically vulnerable to cross-site scripting. There are two types of cross-site scripting. One is called cross-site scripting reflection. Second is called cross-site scripting, access cross-site scripting, stored or persistent. So reflection means, for example, let's say attacker have identified a website is a vulnerable. Let's say this is a website which is vulnerable to cross-site scripting, and as you might know, most of the blogging websites are vulnerable to cross-site scripting. Let's say attacker has identified a website where attacker can actually an attacker has already crafted his fraudulent website. This is a fake website they installed or run by attacker. So attacker will post a comment having or with underlying malicious script. Like this might be a script. If anybody click that link, it will redirect the user or attacker to a fraudulent website. Or for example, if anybody click that, there might be a virus which can be delivered on victim's computer. So this is called cross-site scripting reflection, which reflect on the same session, like for the same user. So cross-site scripting, usually what happens, attacker, it involved mainly two steps. Attacker crafts a fraudulent website and then post a comment on vulnerable website. Vulnerable website means which doesn't check your input, whatever you are typing, whatever tag you are inputting. So like for example, blogging website where you can post a comment. So you have posted a comment with a malicious script, underlying malicious script. Post a comment on vulnerable site with underlying malicious script. Okay, post a comment on a vulnerable site, underlying malicious script, which will redirect the user or victims to attackers attacker's crafted site, or could be download the you can say a virus or malware on the victim's computer. This type of attack, cross-site scripting attack, is called cross-site reflection. Second is called cross-site stored or persistent, which is more dangerous. Okay, it is more dangerous. Attackers, what they do, they inject the malicious scripts. They inject the malicious script on a vulnerable web server or on vulnerable web application and store them permanently. So basically, attacker found a website vulnerable. Attacker has injected the malicious script. Like, this is the website. Attacker has stored attacker had created and inject this particular script on the website, and that particular web script might be, for example, if anybody enter or log into a website, so it will steal their session cookies and forward the session cookie to attackers. Okay, this is called cross-site scripting stored, where attacker inject the malicious script on vulnerable web applications, stored them permanently there, and whoever will visit that contaminated site now will become victim. Like, attacker can do anything when they visit that. So attacker has already installed this script on that website. Now, whenever they will log in, so automatically whatever this script was designed for, it will actually do those action on the victim's computer. Okay, the next is the insecure digital object direct object reference. So this particular vulnerability occurs only if we have the combination of poorly implemented access control system, and you are using sequential numbering or automatic filling of the reference. So what does it mean? Let's understand firstly what is basically direct object reference. Let's understand that. So for example, we have two users, Alice and Bob. For example, Alice and Bob, they have created an account with this bank. Let's say this is a bank. For example, we have a fake bank. So they have created an account with this bank. After creating an account with the bank, so Alice, she got a registration number, for example, 300. Bob, he got a registration number 301. So if the system or this web application, it uses the sequential numbering or automatic filling of the reference. So for example, we have next person XYZ, his registration number is going to be 302, 304 and all that stuff. Okay, the same way. Now the thing is, what is direct object reference here? So for example, when you, let's say Alice, when let's say she logs in to her bank account, she want access her bank account information. So if she enters, or let's say after she put username and password, for example, if she put username and password, and if the browser sent this registration number to web server, then this is, and the data is pulled through the registration number which is sent through the browser. This is called direct object reference, where Alice, she is basically putting her username and password. Once you do that, automatically her number 301, it goes in that HTML in the HTTP request through the browser to the server. This is called direct object reference. So let me write it down. If the registration number, or you can say sequential number is sent from browser to server to request account info, then it is called direct object reference. So basically, Alice, she's basically sending out directly, let's say the registration number or whatever the number is, and this number goes to the browser to this, let's say banner. In the banner, you have your 900 number. So when you put your 900 number and whatever your password is, this 900 number is a unique ID. You actually send this 900 number to the web server, so it travels from browser to the server. So that is called direct object reference. Now, first condition is true. There is a direct object reference. Number two, let's say we are assuming that we have poor access control method or access control system implemented. Then what Bob can do, if Bob knows a sequence, let's say Bob knows 302 might be, for example, XYZ. So Bob will temper the HTTP URL and put, I mean, instead of 301 his, if he was put 302 and try to pull the data, Bob can actually get Alice information. That is called insecure direct object reference. So if then let's say a poor access control, if a poor access control system is implemented, then Bob can temper HTTP request URL, okay, and send Alice or XYZ sequence number, registration number to access their account info. This is called insecure direct object reference. The next is the security misconfigurations. This is basically because these particular vulnerabilities occurs because of the poor configured technologies that are basically used in the web application, the development of a web application. For example, let me give you an idea. Let's say British Airways. So hackers, they had British Airways website. So let me tell you, let's say this is British Airways website, for example, and they have used a script, which is, for example, JavaScript. Okay, so website is basically designed in JavaScript. So these JavaScript, they refer to libraries. In order to execute, they actually get the data from the JavaScript libraries. What actually did hackers did? Hackers, they penetrated the JavaScript libraries, okay? And the website, because British Airways website was designed in JavaScript, so whenever the website execute, these script, they refer to JavaScript in order to execute, in order to adjust the content and stuff like that. Since hackers have already hacked these libraries, JavaScript libraries, so what happened actually, when these website, like British Airways website, this script, it referred to JavaScript library, so they have already tempered that, so they were able to let it communicate, like JavaScript library will forward it to attacker's website. So now what will happen? This website will, rather than getting information or getting the instruction from JavaScript library, this website was starting taking instructions from attacker's website. This is called security misconfiguration. So you have used something in your website which is basically getting instruction from an external library, and that external library got compromised. So now what will happen? Who has control on those libraries? They can actually control over your website. Okay, so poorly configured technologies that run on web applications. As I mentioned earlier, hackers, like I'm talking about the British Airways hack. So hackers successfully penetrated into JavaScript libraries and the website, not only any website designed with the JavaScript, the website which has used JavaScripting and referring to those libraries started sending data to hackers or hackers servers maybe. Next vulnerability is called sensitive data exposure. Sensitive data exposure mean or it occurs, for example, let's say this is you and this is, let's say, your bank account. So you actually this is your bank account, for example. So let's say you log into your bank account through a computer in the let's say net cafe, okay, or for example a public computer. You have used your school's computer, for example, to access your bank account. So when you access your bank account, you know what happens? Sometimes your sensitive information of your bank account, it gets cached within your local computer. An attacker, they can actually pull those cache. They can see what is basically inside those cache using some forensics tool sometimes to get the data which got cached. So when you log off the computer, attacker join the network, they attacker log into this computer, they can get the cache and they can log into your computer or log into your account and do whatever the destructive actions are. This is called sensitive data exposure. Like when you log into a website, that particular website, it actually stores some sensitive data inside the cache, inside the RAM as well. That's basically sometime which could be problematic if you have accessed your bank account or sensitive account using a public computer. So this particular vulnerability occurs when client checks his or her let's say bank account on or using public computer or internet cafe or something like that, using public computer, then sensitive info, for example your cookies, session cookies especially I'm talking about, etc., of bank accounts get cached on local computer. Okay, which attacker can misuse, attacker can actually pull it by using some forensics tools, in fact. Next is called directory traversal attack. Directory traversal attack means attacker access those files, those directories which he or she is not authorized to access by injecting some malicious command. This is called directory traversal attack. The reason for directory traversal attack is poor access control system. So if you have a poor access control system, attacker can access those directories which he or she is not authorized to access by inputting the malicious commands, and they can access the stuff. We will discuss that in detail. Practically, we will do that in our lab. Cross-site request forgery. Cross-site request forgery mean attackers, what they can do is they just have to, like, for example, this is the user has active connection or actively using this particular website. Attacker has to, I mean, during that session when you are actively using this website, attacker has to make you click a link. Attacker will create a link, and that particular link might have been stolen from this website. Like, for example, when you, let me just give you an idea. Let's say you are actively using you are basically using this website, and let's say you have changed your password. When you change your password, there is a URL on the top of it. When you change the password and you see password successfully got changed. Now, for example, if that website, so if the website is vulnerable to cross-site request forgery, what will happen? Attacker can actually copy this. Okay, attacker can copy this and make you click the link. Like, attacker can actually make a JavaScript file, okay, and place that file on the vulnerable website, or maybe send you by using social engineering. Once you click that, attacker can change your password, or your password get changed, or for example, they can transfer funds. This is called cross-site request forgery. Okay, and if this vulnerability is there, and how you can find whether this vulnerability is there or not. For example, when you create a password, let's say you this is you have created account on this website. When you set your username and password, if that username and password shows on the top of URL, in the URL, if you see the username and password is showing up, it means that website is vulnerable to cross-site request forgery. And you can actually, copy that URL, change it up, and send it to anybody and change their username, password, and all that stuff. Or you can change their password, fund transfer, anything can be possible. We will demonstrate that in our lab. So what is basically the things that you need to know? Cross-site request forgery, also called session writing attack. It's called session writing attack. Attacker tricks the user of application having the active connection. So user should having active connection. So user is actively using that website, tricks the user and make him click the link, and that link can be placed on the website, or that link can be sent using social engineering, and then attacker can perform unauthorized actions on the application, like change of the password, for example, fund transfer, etc. This is called cross-site request forgery. So attacker has made some request and you just made him click and change the stuff on the attacker's behalf. Next is called unvalidated URLs. For example, this is you, and if you just like cross-site scripting XSS reflecting, like this is the website and you are basically posting or putting a URL which is basically a malicious URL or stuff like that and make the people click that. So this is called unvalidated URL vulnerability. Like this website, like if you are trying to put any URL, so that application should allow only whitelisted URLs. Like if they find any URL might be a blacklisted URL, or maybe something which might be a fishy kind of URL. And how we can get that list? By using virustotal.com. We can, whenever anybody upload any URL, the web application should check that URL on virustotal.com. If that URL found a fishy URL, found basically a malicious URL, so that web application should not allow the user to upload that URL or the website, or that link on the website. So this is basically called unvalidated URL. If a web application doesn't check the authenticity of web links uploaded by users, it is called unvalidated URL. So if they don't check the validity, like for example, if you use facebook.com and post a comment and put your website, let's say a fake website, or for example, malicious website, if you're able to put that website in a comment or so that is basically unvalidated URL issues. Last but not the least is the using known vulnerabilities. For example, if you found a web application is not updated, didn't patch over the affected areas, so that particular is called vulnerability, the known vulnerabilities, existing vulnerabilities. So vulnerabilities that occur because of outdated because of outdated, or you can say old features offered by operating system, database, or web server. So this is called using known vulnerabilities, and this is most of the time that's the starting point. Attackers, they, for example, the SQL injection attack, cross-site scripting attack, and stuff like that. Attacker try to find the known vulnerabilities first, test the website against the known vulnerabilities, and then attacker go for the novel vulnerabilities and all. So these are the 10 vulnerabilities identified by OWASP, Open Web Application Security Project. The next is the countermeasures. How we can avoid these vulnerabilities? Is there a way we can avoid these vulnerabilities? So in order to test the vulnerabilities, in order to test application for vulnerabilities, there are two methods. For testing of web applications, we have two methods. Okay, there are two methods. The first method is called SAST, or you can call it static application security testing. And the second method is called DAST, which is dynamic application security testing, the same thing. So SAS is basically where we analyze the source code of an application for vulnerabilities. So it is like more technical, like we analyze the source code of vulnerabilities. Okay, if the source code is available to attacker. Second is called DAST. DAST is basically where we do the analysis of running application for vulnerabilities. That's called DAST. Again, if the source code is not available to attacker go for DAST. SAS is basically where the internal vulnerability assessment people or security pen testers, they actually use SAS just to look for vulnerabilities in the source code. Whether it's basically validating the input, if it is testing the URLs and stuff like that, all that stuff, testing the cryptography stuff and all. DAST is basically where we do the analysis. If you attackers, they do the DAST, and this book is mainly based on DAST. The first step is in the vulnerability assessment. Internal vulnerability assessment is information gathering, where most of the vulnerability assessment tools or attackers, even they first gather information about the application. What kind of information? Like, for example, does web application is connected to a database? Okay, if it is connected with a database, what kind of database it is? Okay, number two, does app has static or dynamic pages? This is the second information that we actually find out about application. Number three is the programming languages. Programming, or you can say scripting languages to design the app. So which languages are used to design that particular application? Then access control infrastructure, access control and authentication, infrastructure, like which access control method has been implemented, which authentication factors they are using. Number five is the server details, like on which server the website or that web application is running, what are the operating system, IP address, and security configuration. So these are some of the information that we collect before doing any kind of vulnerability assessment or any kind of web application attacks. Next is the authentication testing. That's a very important concept, very important thing. You know what, for example, This is the web application. Let's say that's your web application. So most of the web application, they don't perform authentication using the same web application or using the same server. Instead, they basically use this a separate or independent server. For example, it could be active Windows directory. For example, we are using that access control for authentication. So when user will try to log in, what will happen? User will go, authentication information will be forwarded to, let's say, this is the web application platform or the form. Okay, this is the form. For example, when user enter username and password, this username and password will go to active directory or access control or authentication server, and after verification, then authentication request, or you can say this will be forwarded to web application, like whether user can access or not. If not, then it will be dropped, otherwise user can access. So let me repeat. User firstly complete the form, username and password. After taking user information, it will be forwarded to any kind of active directory services for authentication, or any kind of authentication services. Then information or whatever the request will be, it will be forwarded to web application, or it will be dropped if the username or password doesn't satisfy the active directory. Now, there are a couple of questions. The first question is, we need to find out how they transmit the data. If it goes in an encrypted form, which algorithm we use. Then we need to see whether this server is patched over or not, if it is fully updated or not, okay, and stuff like that. And now the form, how we are getting the information by using get tag, post tag, what kind of tag we have used. So there are a couple of things that we do in authentication testing. So in authentication testing, as I mentioned earlier, many web applications require that a server other than web server to authenticate the users, okay, like this server. So in this case, what happens, we see how authentication info is passed, like encrypted, unencrypted, authentication server properly patched or updated, whether it's properly patched or updated or not. These two things that we need to find out. Next is the authorization testing. Most of the web application developers, what they do, most of the web application developers, they use robots.txt file. Like they use this particular file, and for example, if they don't want the users to visit certain URLs. So most of the web application developers, they use robots.txt file, or they use the some hidden fields in the table to restrict the user, to enforce the access control instead of using the privileges. Like when user will try to request, like let's say this is you, and you want to access for example a URL. So rather than checking your privilege, like what kind of user you are, firstly they will see what is your request. So they will execute the request. If they find you are trying to access a website which is not permitted, and this is mentioned in the robot.txt file. So what will happen? Like they are executing the URL or user input without checking the user privilege, like what kind of user it is. So that's basically a problematic thing. User can escalate the privilege. Like remember the insecure direct object reference? Exactly the same way. Like they are executing your instruction first before checking who are you, like what stuff you can access. So they are executing it, hey, just to see, are you trying to access something which is in robot.txt file which you are not supposed to access? Okay, if not, then of course the next level. So basically you are executing your user input first. Again, you are basically allowing the user to input something and checking whether it's basically user is accessing the secure directories or not. This is basically we need to check, and that's called authorization testing. So most of the application developers use hidden fields in database tables, and obscured URLs like robots.txt to enforce access control instead of checking user privileges before processing a request. So before processing a request, before checking the user privilege, they actually process the user request just to see whether user is not trying to access the websites mentioned in robot.txt, like obscured websites. So this is basically like, because of this, a low privilege user might access the URL and get the escalation. That's authorization testing. Next is the input validation. We need to actually do the input validation, like to avoid SQL injection attack, to avoid command injection, to avoid cross-site scripting. Just we need to validate user input before processing. So wherever user will input something, we need to process that. There should be a program, there should be an application which will process user input before, which will validate user input before processing it. Next is the cryptography testing. We need to test the HTTPS, the certificate, need to get the certificate. Algorithm testing, like cracking of algorithm, just finding vulnerabilities of algorithm and see whether it can be cracked or not. Last is the client-side testing. For client-side testing, let's say whenever you visit a website, let's say this is user, when you visit this web server, so server respond you back. So we need to check it out before making the website online, before publishing the website. So you need to test the website, like when a user will visit the website, what will be the response, whether it's not, is it exposing some secret information or classified information. We need to check it out to avoid the, if you remember this, sensitive data exposure, just to test it out. When anybody visits the website, what kind of data will be stored or what kind of data will be cached. So client-side testing, test the information sent by server to client. Okay, response. Does application store sensitive data on client's machine in an insecure manner? Okay, for example, like get tag, etc. So that's basically the way how we can avoid the vulnerabilities and avoid these web application attacks. In our lab, we will practice all these stuff. We will discuss all that stuff. If you guys will have any questions, do let me know. Thank you very much.